All right. So today's week 4, day 2. Man, we're almost coming up on a third of the way through the material. First 2 weeks, first 2 weeks in particular, as you all remember, were real fast. Like lots of challenges every single day. Not last week we did mostly OO. This week we're going to focus entirely on SQL, and we're going to focus on something called active record, which we'll talk about at a later point. No matter how you feel about JavaScript and Ruby, I did see someone who's like basically like, I wish there was more JavaScript instead of Ruby, and other people are like, I wish there was more Ruby instead of JavaScript. No matter what happens, SQL is forever. SQL will never ever go away. I mean, there are people, like, if there's ever a language that will literally never go away for all of web development and just technology time, it's going to be SQL. SQL stands for Structured Query Language, and that basically is the way that we interact with databases. And it doesn't matter if you're really good at Ruby or you're really good at JavaScript or you're really bad at like either of those two things. Like, SQL is an entirely new language. It's a fresh start for everyone. Like, everyone is on equal playing field when it comes to this. And the thing that most people like about SQL is that it's extremely structured. It's what's called a so there are loosely typed languages, kind of like Ruby. You can kind of like convert a string into an integer and turn that into a float, and like you can do all these crazy things with Ruby because it's what's called a loosely typed language. A strongly typed language is a language like SQL. There's one way to write it, and there's one expected output. If you mess up anything, they'll let you know. That's the good part about SQL. Like, if you mess up anything, they'll immediately let you know. So there's only one way. There's multiple ways to get the same desired output, but there's pretty much like one correct way to get there. So it's both good that it's like it'll let you know if you've done something wrong, and it's going to be very similar every single time. It's also bad because it's harder to type. It looks more like actual like code when you read it. Now, there are many different, they call them flavors of SQL, meaning that SQL is just at the root of it, it's just structured query language. It's how I talk to a database. But there are many, many different SQL databases. And maybe some of you have worked with these in the past. Maybe some of you have heard of these in the past. There's Oracle is a SQL database. MySQL is a SQL database. IBM DB2 is a SQL database. Teradata is a SQL database. SAP is a type of SQL database. Like, all of these different things all use SQL in it, but there's very minute differences between each one of these. Actually, there are differences between each one of these, but they all use SQL. The one that everyone is kind of settled on is called Postgres. Postgres is highly scalable. It is highly efficient, and most big companies are moving away from like MySQL and like Oracle and like these big enterprise level databases and moving over to Postgres right here. So let's kind of get into it.
You could just quickly.
Sure.
You remember back in the day, you used to have the guy in the basement with the server. What language were they querying the database with?
SQL.
On Linux kernel? On the Linux kernel, they were using SQL.
Probably.
Basically.
Probably. Okay. I can't answer that for certain. The short answer is I don't know. I'm guessing it's going to be SQL.
Okay.
Yeah. All right, so let's talk about SQL. So SQL, if you've done the reading, stands for SQL. SQL stands for Structured Query Language. And what does RDBMS stand for?
Relational Database
Management. Yep. So SQL is a type of relational database management system, and there are two halves to this particular system. The first one is, how is my data stored? So there's two important parts about these relational database management systems. One is, how is my stuff stored? There's an idea of tables and columns and rows, and then the second important half of it is, how do I query it? How am I supposed to talk with this relational database management system? And that's using SQL, the structured query language. So this is a little about what a table looks like. It looks very, very similar to a spreadsheet. when you visualize it out like this. So you have tables, which is just the entire thing. Like the students right here is a table. Then we have, so like I said, then we have columns which go vertically. And what we can see here is like we have ID, the ID column that goes straight down. Like every single record, the first record has an ID of 1. The second column has an ID of 2, so on and so forth. There's a column for first name, there's a column for last name, and on probation.
Does every table automatically generate IDs?
That is a great question. So yes, in SQL databases in particular, every single table, whenever you enter a new record, will automatically increment your IDs for you. You need to tell it to do that, but it will once you set it up. There are also things called NoSQL databases, which is a database that doesn't keep track of IDs and is basically a giant hash of information. So that's really good for things like the DMV. When I'm looking up a car by its VIN number, like I don't want to search through every single one. I can just have a key of the VIN number, and the value is going to be a whole bunch of stuff. So you can't really say one is better than the other. Like you can't say SQL is better than NoSQL because it serves its own individual purpose. I'll say that SQL databases are more popular than NoSQL databases. So again, the table is this whole thing. It consists of columns going up vertically. It also consists of rows. And you can kind of think of rows as just entries inside of the database. Another important concept that people need to be aware of is something called a schema, which is basically, you can read it and it's like very, very difficult to understand, but it's basically the design of your database. So we're going to do like a challenge, I think it's today, if I'm not mistaken, where you're going to be designing Uber. Now, if we think about these things like, how would you design Uber? Like at the very, like if you were doing Uber 1.0, what tables would you need to design it? Or if you're doing something like Blue Apron, which is that like a meal prep service, like how would you create all the tables to do that? So we'll think through those things in just a little bit. But a schema, you can read, like you have access to all these slides, but essentially it's just how am I creating my database? Like how am I designing it? A schema consists of many different tables. So a schema is kind of like, let's say I have, let's do Amazon.com. Amazon.com, I'm going to create a schema for Amazon.com. I'm going to have, inside of that schema, I can have many different tables. Probably have a users table, maybe a merchants table, maybe a books table or something like that based on what I'm selling. And maybe I'll have like a purchase orders table. But we'll get into that in just a little bit. Tables are identified by a name. So I'm going to do the way that SQL is created. It's going to be create table students, create table addresses, and you can write pretty much anything. So it's create table and then the noun. Now the noun is supposed to follow a particular naming convention. One, it's supposed to be all lowercase with snake case to determine it. It's supposed to be lowercase with snake case, and it's also supposed to be plural. And the reason behind that is kind of like if I just have student table. Are you talking about one student or are you talking about multiple? So the idea is kind of like when I say it's a students table, I know inside of there are many students. If I have a bunch of addresses and I have an addresses table, inside of there is a bunch of different addresses. So some naming conventions, if you are talking about people, purchase orders, or likes on a post, maybe a good table name for the people would be persons, because that's a duplicative. That's a plural noun for people, for a person. If you have purchase order, this one's easy, purchase orders, because I have more than one. Likes on a post, I would just write likes, something like that.
Name examples is a good name too.
What's that? Yeah.
Table name examples is a good name too.
Exactly, yeah.
So people's already plural, but it doesn't have an S, so that's the problem? Like it needs an S on the end?
Yeah, that's what I would recommend. Yeah. So you could do people if you like. Again, there's no, you can name it whatever you like. Just convention in general just has an S at the end. So it's like, this gets particularly difficult with like things like oxen. Like, what is the plural for ox? Like oxes? Like I guess you could do oxes or oxen or, you know. But you probably aren't going to write a database for oxen, right? If you were writing banking software, it's checking accounts. You know, there are many different checking accounts. There are many users that come here. There are many employees. There are many badge numbers. So you probably will never get to that point. So I guess people and persons is kind of a bad example, but you always want to keep the main thing is whatever you're storing, just make it a plural on the right side. Now we were talking about schemas. A schema is like the overall design of your database. You have inside of a schema, you have many different tables. And then inside those tables, you have columns. And every single column has a name. And generally speaking, you want to be lowercase singular nouns. So it's a lot of small little minute details you have to memorize. So tables are plural, columns are singular, because you're talking about one person's first name or last name or on probation. So this, if I were to create a table called student, this is generally how it would look. I have create table and then the table name, parentheses, closing parentheses, and semicolon. And then these are all the columns. Remember, those columns are those things that go vertically. So it's kind of like ID, first name, last name, on probation. It's the header column of your CSV file. It's the thing that the cell that you freeze on your Google on your Excel spreadsheets, so that when you scroll up and down, you can see like, oh, it's first name, birthday, email address or something like that. So columns are basically just like what contents are going to be going in here: first name, last name, on probation, ID, things of that nature. Now, you may have seen like when we looked over here, like ID, integer, varchar, boolean. Basically, you're basically telling your database these particular columns can only hold this type of data. It's not like an array where you can throw in numbers, other arrays, hashes, strings. Like you can't do that. You have to be very, very strict. And this is what I mean by like this is a very, very strongly typed language. It will only accept what you tell it to accept, and it will tell you when you're wrong. So basically, the ID, I'm only accepting integers, only accepting numbers, whole numbers, to be exact. First name, I'm going to accept characters, a string up to 255 characters long. Same thing with last name, and then on probation, a Boolean, I'm only going to accept true or false. So you set those expectations ahead of time so that when you create new records, it's not going to save unless you want it to save.
Yeah, I was going to say Twitter or something. They have a character maximum 200.
That's perfect. That's a great example. Yeah, like we have, if you're thinking about tweets, a tweet has an ID because it's a SQL database. They have a posting time or something like that, like what day did you post this and what time did you post this, and then it's going to have a tweet, and it's going to be varchar of 140 characters. Now I know it's 280 now, but does anyone actually? Quick detour. Does anyone know why it's 140?
Anything more would be a tweet, would be a post.
I mean, that is technically true, but I think the idea was like you should be able to text it to Twitter and then be able to post. I think this was like 2009, and I think there was a limit on how many characters that you could text to. So I think that's where the limit came for a tweet. Now, these are other different types of column types, and it really depends on like the database system, like the flavor of SQL. Remember I said earlier we have Postgres, MySQL, MS SQL, Oracle, Teradata is another one. Like those are all different flavors of SQL databases. And there's going to be small differences between each one, but you can always, most of the time you can rely on these particular ones. So integer, numbers from -2 to the 31st power to 2 to the 31st power, decimals, varchar, text, date, and stamp. The difference between a varchar and a text is varchar goes up to 255 characters. After you get to 255, you're just going to do text. So if I'm going to save a email address, I'm going to do varchar 255 because I'm not expecting someone's email address to be more than 255 characters long. But if I had like a bio section and people are typing out like a paragraph or two about themselves, I'd want to save it as a text because it goes past that 255 character limit.
So is it up to the programmer?
It is up to the programmer, yeah.
Max character.
Exactly, yeah.
So
And then
like common standards, like first name, last name.
I would say this is pretty standard. Like your first name would be stored as a varchar. Your last name is usually a varchar. Most people's names are not more than 255 characters long. Maybe there is somebody in the world with longer than that, and then they're the exception to the rule. But this will fit 99.9% of the people.
What about like an image or something bigger than this? Like if you have to worry about space.
Sure. So yeah, you are able to save images. You're able to save songs. You're able to save like all of these different things into a database. We won't worry about that quite yet. But yes, you are able to store those things. You had a question too?
And then you said for bio you would use text, so that means in the bio they wouldn't be able to use like characters like a period or anything.
So again, the question was like, if you were to create a biography of somebody, like would you store it as a varchar or as text? Again, varchar is a limit, like a hard limit between 1 and 255 characters. So if you are more than 255 characters, which is what, like 40 or 50 words or so at most, like for a biography, you might be writing a 2-3 paragraph thing about yourself. You just save it inside of text. It's just going to be saved as a giant string, but it's more than 255 characters. That's all.
Is there more column types, or is this just the standard, or like the basics?
Question was, are there more column types, or are these just the basics? There are a lot of column types. Like nobody, unless you're what's called a database administrator, DBA, like these are professional people who literally all they do all day is like very advanced SQL queries and things of that nature. There are many of them that database administrators know that I don't know. But these are the common ones that you're going to use as a developer. Again, it's kind of like if you change your own oil, like you're only going to use a certain set of tools, but how many automotive tools are there to do different things to a car? So it's a similar concept like that. Some things as we're thinking about creating your schemas and you know, if you're creating your application and you're thinking about what data you're going to need, your product's going to evolve over time. Like there's a great picture of Jeff Bezos, who's I think now the richest man in the world. Jeff Bezos, early Amazon. Early desk. I don't know if this is a thing. So this is a picture of Jeff Bezos in the 90s or the late 80s, thinking about Amazon.com. Now, when he's first creating Amazon.com, like it's crudely spray painted on the wall. It's falling off. He's got these old computers that basically act as fish tanks now. Like you can kind of imagine when he first created this, he had a grand vision, but obviously I only have enough cash to get me through the next month. I only have enough XYZ to get me through here. Like, I mean, he also looks way worse back here than I feel like he looks now. Maybe it's the fact that he has $119 billion or something like that, and he can get some sort of fancy clothes and things like that. But the idea of why I showed that picture between him and now, him then and him now, is that Amazon.com at the beginning was just a bookstore. It was at the start of like the HTTP, like everything was going on the internet and online commerce was becoming popular. And he said, let's create an online bookstore. You know, so at the beginning, Amazon just sold books. That's all it did. So it had probably a few tables. Users, so you can log in, orders, so you can create orders, and books. It's really about it. Yeah, maybe a few join tables, which we'll talk about in just a second. Maybe 5 or 6 tables at most. You know, users, orders, books, categories like of books or something like that. Like not a ton of stuff. But as it evolves and as your product evolves, you're going to add more and more stuff. That's going to be certain. Now Amazon sells everything, household goods. It has Amazon Prime Video. It does like, it's a competitor for Netflix, not really, but it's a competitor for Netflix. You know, they do drone delivery. They did phones for a little while. They're doing smart home stuff. The idea is,
Didn't they buy Whole Foods?
they did buy Whole Foods, yeah. Or I think like 10 or 12 billion. I don't know. Somewhere in the less than $100 billion. They bought Whole Foods. But just know that the only thing that's going to be constant when you write software is change. The languages are going to change. Your customer needs are going to change. Your product's going to change over time. Your database is also going to change. So what I want to really stress is, like, you're going to need to create new methods. You're going to need to refactor code. You're going to need to update your database, remove tables, add tables, things of that nature. And the main thing that I want you to know is that changing that is not cheap. It's very, very expensive to do so. Not in the sense that like, oh, I'm going to it costs me actual money to like change it. Like your software will do it like that, but you're spending a lot of time and a lot of resources for many, many different developers to think about like what's the best thing I can do to make this more usable in the future. If you are moving from like an Oracle's database to a Postgres database, like you can't lose any data. Like your first customer in 1990 to your customer now, you can't lose any of those people in your database, because if you get audited, you're screwed. So all that to say, be very, very careful and take a lot of time when you design your schema. It's very common just to say, let's just create a quick schema. We just need to get this out the door and then we'll figure it out later. Don't do that. Like take the time when you're figuring it out, fully understand like what are the implications of putting this table here? Is there anything negative that can happen as a result? Groupon.com is a great example of this. They needed to grow super fast. They went from 0 to IPO in 6 years. That's a lot of money and that's a lot of time, and a lot of people were about to get paid. But to bring a company from 0 to IPO in 6 years also means that you take a lot of shortcuts. They weren't thinking super far ahead. They were just like, let's just get to IPO, let's just get to IPO. And they were making a lot of bad decisions along the way, to the point now where you can't touch the database. If you touch the database, something could break and then your whole website goes down and things like that. It's like, that's very, very brittle software. You don't want that to happen. And it happens at every organization, no matter what. But for you, make sure that you're taking the time when you design your schema. And yeah, if you're convinced that you wish you had a different schema, the time to make the changes right now, today, because it'll never be cheaper than it is right now, because there's more data coming in and being saved into your database every second. So we're talking about like Twitter. At the beginning, Twitter was written in Rails, and they were getting around 200 hits a second, roughly, to their database. 200 hits a second is a lot of hits to your database that's being saved in. Then they grew. Now they're at 20,000, 100,000 per second. Like that's how many tweets people can actually throw in around the world at 1 second. So you have to think of really good ways. Like there's very big implications if you design your schema poorly. And part of like designing a schema really well is the concept of single responsibility. We talked about this all the time. Daniel, what does single responsibility mean?
That everything does one thing.
Yeah, the idea that everything does one thing and does one thing well. Like I can teach and write software decently. Like that is what I can do. I cannot go to your house and fix your toilet. Like that is something you hire a plumber for. I'm unable to do those things. I do my job well so that I can pay other people to do their job well. And that's like the most efficient way about going about it. So yeah, smaller is always better. And similarly, when you talk about like storing data, like having one table do too much is probably a bad idea. So let's just take a look at this. We have one table here, and the column names are ID, first name, last name, on probation, line 1, 2, 3, city, state, and zip code. Is this following the single responsibility rule? Okay. What types of, like, what's going on here? If you could separate this into 2, 3, 4 tables, what would you call this? Like, what would one table be called and what would the other table be called?
Address and student.
Yeah, it looks like this one table contains two types of data: the address over here on the right, and then the student. And that's exactly what's going on here. You can actually split this right down the middle. We have students and addresses going on right here. So another thing, so make sure that your code and your schema is very single responsibility, and at the same time, keep your code dry. Don't repeat yourself. So I've got two things right here. I have students and I have addresses, and I have a bit of duplication when it comes to first name, last name on the students and first name, last name on the addresses. If I were to keep it like this, what are some things that you can see into the future that's an issue?
When you try to query a first and a last name, you're going to be looking at two different tables. So you have to say, well, which table is it you're looking at under this name?
Yeah, that's true. So yeah, if you're going to query by a last name, you have to query on two different tables for the same piece of data. But with this, another thing that you can think about: what if a student changes their name? Parents get divorced, they get remarried, and then now the whole family, like for me, there was a girl named Jackie Hemsworth, Jackie Collier, who I also think lives in Chicago, which is weird, but she went to grade school with me until from K through 12. And it was always Jackie Collier. And then one random day in 6th grade, she's like, oh, my new name is Jackie Hemsworth because her mother got remarried. So like obviously these types of things change over time, and like on probation will change and things like that. But what downsides can we expect if a student changes their name? Like what are some of the repercussions, do you think? And you have two different tables.
Forget to change it in one.
If you change your name in one place, you have to change it consistently. So it would make sense to make the name sort of like a key value, something that like everything filters into. From the name, you get all this information about a person from their name.
I agree with half that statement. So Sharif and Aaron both got it in the sense that it was like you have to change it in two. You have to memorize to change it in two different places. I wouldn't save this as a key value pair because then you're moving into NoSQL land, and I was like, this is very like it's NoSQL. You have to be very, very. You have to have a really good reason why you're not using a SQL database at that particular point. So yeah, you would have to. My opinion is we should keep it as a SQL database, and it's kind of like if I were to update a last name here, I also have to update it somewhere else, and you have to know to do that. That's the other issue. You have to actually know the database so well, and you have to teach other people to know it so well in case you get hit by a bus or you decide to quit or something like that. That you have to update in two places. So an alternative to eliminate this duplication is what's called using a foreign key. So inside of this students table, I've added on a column called address ID. And this address ID is just a number, and it connects with the addresses on another table, the ID numbers on another table. So all I have to do is update it one time here on the students table, and then their address, like I don't have to keep track of that duplicate information. Again, I'm doing what's called a foreign key. So I'm associating this particular table here with this particular table connecting the foreign key of 4 to the primary key of address. Again, foreign key, it lives on like the host, you can kind of think of it as, and the primary key goes to the other person.
Was it like a required relative kind of?
It's kind of like a required relative. It's like Tiana Lowe, who's not on probation, has an ID address of 4. Okay, well, I don't know what that is right now, so let's look into address and find the ID of 4. Okay, this is their address, 381 Maple Street in Chicago.
Which one's the foreign one again?
Foreign key, and then primary key. This is primary key, this is foreign key.
Do you have to make sure that the primary keys and the foreign keys are all unique across the entire schema, or is it that the keys can kind of be duplicated? Like you could have key 1 and addresses and key 2 and like where you
great
key.
Yeah. So in terms of primary keys, they will always start at 1 and increment. And the idea behind it is kind of like, because there's a students table, there's a primary key of their primary identifier is this ID here. So students at 1 is not the same thing at addresses at 1. This is kind of a bad example. Well, for your question, it's a bad example, but in reality, there are 3 other records above number 4. So the primary key for each table starts at 1 and moves upwards.
You can't just match them by ID number if it's all in the same order. If ID 1 and 2 in students is the same as their addresses on 1 and 2, you can't match them if it's like in order, like kind of like an array. Like
one student wants another address.
Okay.
The other thing, I'm not sure what the question was.
If you had addresses ID 1 and 2, they just so happen to be like the same as students 1 and 2.
That's fine.
You can't just match them that way. Like
no,
okay,
I would not do that. No.
Okay.
So basically, if you have a foreign key, you have to have a primary key as well.
Yes, that is accurate. Yeah. So in order to even save a record, you have to have a primary key. So like this foreign key of 4 and 5 wouldn't even exist if 1 and 2 didn't exist. So primary key is just like the table, this particular record's number. The foreign key is basically saying I'm looking on another table and I'm looking for their primary key where it's just going to be 4.
So in the beginning, when we're getting all the information, like you wouldn't know how to split it up. So maybe just getting all of the information and then taking a step back and looking at it.
Exactly, yeah.
Yeah.
The question was, like, how do you know where to split? Like, what if I just wanted students, but like, is it okay to start with all of the data just in one giant table and then splitting it out? That's a legitimate way of doing it. It's probably, you'll get better at it over time. You just kind of know, like,
I'm gonna need this.
yeah, pretty much. It's kind of like saying, I don't know if this is accurate, I'm going to fire my weapon until it doesn't fire anymore, right? Rather than I'm going to fire my weapon so many times to the point where I know how many shots I've fired in a certain amount of time, or like maybe the gun is getting lighter because all the bullets are going away. Like, you know, like I'm guessing you all know when to reload without like emptying out your cartridges. No, or you just empty it out. Okay.
How do you know when to do that?
I don't know.
You gotta count in the middle.
Okay. All right, that's fair. Maybe I was wrong, but it's like the idea of like knowing. It's the idea where you're in your car and you're going to drive your car until it doesn't run anymore, or you're going to look down at at your thermometer of how much gasoline you have. So it's like the more you drive, the more you realize like, oh, this is how long I can go. Or it's like I filled up last Sunday. I've driven to work 4 days in a row, and I know every 5th day I need to fill up. Like, you know that in the back of your head, like I need to fill up today or sometime soon, otherwise I'm not going to be able to get home. And similarly with this, you can write all of your code out in one place and then just kind of say like, this is probably one thing, this is probably another thing, but you'll most likely, you'll see it in a second when you start doing stuff. It's kind of like, well, this could probably go in another table. This could probably go in another table.
I think it's the same question as Raymond had. So if you start your address ID and your ID, like the first entry, so this is 1, 2, 2, that doesn't matter?
It doesn't matter.
Okay.
Yeah. The question was, what if your ID and your primary key and your foreign key have the same number? Doesn't matter. Doesn't matter at all. Like, because this is referring not to here at all, but it's referring to another table's primary key. Some things also to think about. Make sure that you keep your data integrity. Like, there's things like not null or column uniqueness or things like that. It'll protect you from a situation like this where it's like I saved it twice because I'm not looking to make sure that I've already signed up. Now, there's a major healthcare company called Blue Cross Blue Shield who saved my account information twice. They did not do this. So that whenever I sign in, or Ventra is also a really bad one. So Ventra is if you ride the Chicago L line, like you buy a card from Ventra. Ventra is horrible because I have 2 accounts with 2 different usernames saved to the same email address. So when I sign in, half the time I get like one particular login, and half the time when I sign in, I'm on a second different type of login. I was like, all right, so I have to call in. I said, I have 2 accounts saved to one email address. They don't understand what that means because they're not technical people. I was like, you just look at my account like, oh, you have 2 registered cards here. I was like, yes, can you delete one of those? And then they finally had to delete it. And then if you've ever dealt with like a healthcare company trying to do the same thing, it took me like 4 weeks to try to just delete my one thing until I yelled at somebody on the phone because I was like, I'm losing my mind here. Just delete one of the thing. They're like, okay, I'll delete both of them. I was like, okay, just delete both of them. But you don't want your experience to be a frustrating one. So make sure that when you're talking about things like email address, like if they're already signed up, they're already signed up. You know, that's how they can tell you, like, you've already signed up for this service. Do you want to log in instead?
Just do that with a conditional statement or some type of validation.
It's a SQL. There's a SQL validation that says like unique true. Like you have to confirm that it's like that particular entry is going to be unique to all the other entries that are already in there.
You're gonna have multiple validations.
Yeah.
In the database, it's like the last line. Once it crosses this validation, over.
Yeah.
But you'll have multiple ones.
Yeah.
Okay.
So I think that leads well into this next little point. Take a look at the passwords here on the right side. So these passwords are saved as a bunch of disgusting garbage, right? Like nobody can read this. No one knows what's going on. And this is actually not what anyone's password really looks like. There's one thing I want to drill in everyone's mind, which is do not store passwords in plain text. If you learn nothing else in this entire bootcamp, do not store passwords in plain text in the database. Because if your database gets hacked, they most likely, your users probably use the same password for your Chase account, for your Amazon account, for your Bank of America, for your mortgage stuff. Like once you have one username and one password, you can probably just brute force it against everything and then figure out like where this person lives, their social security number, and you can do a lot of fraudulent activity. So what happens is people will enter their passwords. It'll run against a hashing algorithm. Then there's like PhDs that work on these hashing algorithms, and it's saved into the database as this. So that in the case that, you know, Russian hackers or Chinese hackers or something like that get into your database, they can look inside here and be like, I don't even know what that means. I know that this is hashed. I know it's going to take me, you know, somewhere in the vicinity of like 1 million years to try out all the different combinations to brute force it to get this to go backwards. Now, there are quantum computers. That's a topic for another time. They can crack this in about 5 minutes. So there's nothing is ever like super, like probably not 5 minutes, like less than a day they can crack it, right? Not 1 million years that it would usually take. Maybe supercomputers can crack it in 5 minutes. I don't know, but the idea is never store your passwords in plain text. It should always look like some disgusting bit of garbage like this. What was the question again? I think there was a good lead in. Oh, so your job as a web developer, as we're starting to develop more and more advanced applications, is always assume that the person on the other end of the computer is trying to attack you. It's not true. You know, 99% of the people are just regular consumers of products, but always assume that someone's trying to attack you. So you want to hash your passwords. You want to have all these different validations before you save things in. What if you had a not null if you didn't have a not null constraint for a password? Anyone can log in as james@example.com. Like you don't even need a password to log in because it could just be saved as an empty string.
So when you're thinking of column data type, not in plain text, what would be in the dropdown for password?
Passwords should be saved as a string because it's
string.
It's a string because
Okay.
it's a string.
Okay.
Yeah. Like ID should always be a number, an integer.
Okay.
You know, if you're going to say how much did this item cost, it should always be like a float, like a decimal, because it's you want it to be exact. Yeah, basically, like what happens when James logs in, like which password are we going to check against? So that's a little bit about just some of the, like a little bit of the background when it comes to SQL. What you practiced yesterday and over the weekend, if you decided to get started, was something called SQL queries. Like, how do I get data out of the database? So I'm using the language called SQL to get the data out. You're going to be dealing with many different things, but most in this particular order, it will be like this. The most popular ones can be select. Select is like get me information based on the query that I write. Then there's insert. I'm going to put something new inside the database. Update something that I'm going to find a record in your database and update it, and then delete. I'm going to delete a row that matches some particular query. So the most common one is going to be select. So select star from students. The way that this reads is I'm going to select, so give me some sort of data. Select star means select everything from the table called students. So in this case, we have Tiana Lowe and Elda from our earlier thing. If you want
snipes before, I think that's a typo, or the database screwed something.
It's okay. I'll update it later just for you. How's that?
Right on.
Okay. But let's say you don't want every single thing from students. Maybe you just want their ID number and their first name. So you can say select just the ID number and the first name from students. So over all the records, I just want the ID number and the first name, which differs a little bit from select star from students, which gives me the ID, first name, and last name. Maybe you want a specific condition like select ID and first name from the students specifically where the ID is going to be equal to 2, and that would give you LDA. Or it's kind of like when companies are starting to figure out who they want to lay off, if they're going to do a large round of layoffs, it's like select the ID, the first name, the last name, the email address from employees where like age is greater than 50 because they're closer to retirement age and they can just knock off a whole bunch of people like that. They're usually paid a little bit more. So there's no shortage of like business applications for SQL. So where is a very powerful clause. You can read all of this at your leisure. But it's kind of like you can do like where some column is equal to this, where it's not equal, where it's greater, like select for me, like when you turned 18, everyone in this room received a Gillette razor, right? Or got a phone call from a military recruiter of some sort. I think that's what everyone happened in my town, at least. So it's basically it's just a giant where clause to be like select like phone number from like all men where like birthday is like where the age is like 18 or something like that, and then they are going to give you a Gillette razor and they're going to give you a call to join the military. And there are other ones that you can do with where as well. So you can kind of take a look like where the first name is Andre, select everyone from enrollments where the grade is not an A, select all the classes where the credits are between 3 and 4. If you only need 3 credits to graduate, you're not going to take a 6-credit class. Select star, select everything from the enrollments table where the grade is either A or B. Select everything from classes where the name is like art, %, and credits is greater than 3. This percentage sign here, I don't know if it says, it doesn't. It basically says starts with the word art and ends with anything. You can also do percentage art, which is starts with anything and ends with art. Insert, like we talked about, we're going to create a new record inside of the database. So insert into the particular name of the table, and I'm going to pass in these particular 3 things in this particular order: first name, last name, birthday, and the values of those are going to be Michelle going to first name, DuPont going to last name, and the birthday being 2/11/82.
So is that creating new columns?
It's creating a new row.
A new row.
Now, if you screw up the row with the information on it, will it create a new one or kick it back and say you screwed something up? Like if you got first name wrong with like a dash.
It won't. That's the thing. Because, well, first name, what would be like the data type that you want to put in? Probably a varchar. So it's going to accept pretty much anything. Last name, same thing. Birthday, it looks like it's also a varchar, just a random string of anything. So you have to be very careful when you're putting stuff in. Like, who knows what can come in. Update is basically let's find something and then update like a particular record. So I'm going to update the data, the table name, and then I'm going to set like line 1 equal to whatever and zip code equal to whatever where this particular thing is true. And then delete is pretty simple. Delete from addresses where ID is 2. I'm going to delete the second one, the second entry in the database.
But once you delete, is that recoverable?
Nope, it's gone forever. So you want to delete things as infrequently as you can. It's better just to like set a flag on it, say like disabled true or something like that, rather than to delete everything. Specifically for Groupon, the way that we did it was when you redeem your Groupon, it doesn't show up in your available Groupons anymore. We just had a flag on it rather than delete it. So I can actually go back to when my first Groupon, I know all my purchase history. And if they were to delete it, I wouldn't be able to see my purchase history. And that's bad for some people. Some people don't care. So you want to be careful with, you generally want to do a where condition whenever you update or delete things, because the issue is like, if I do update addresses, I'm going to do an update statement to the addresses table, set line 1 equal to 200 Church Street in 60010, which I think is Evanston. If you do this without a where clause, like we saw over here, with this where ID equals 2, then every single person moves to 200 Church. That's an issue. Or if I do delete from addresses, instead of delete from addresses where ID is equal to 2, you just deleted your entire database. for addresses, and this could be, I mean, absolutely devastating for you. You could probably get fired. So I think that's it. I think that's all the slides we had. So today what we'll do is we have we'll call, I say pairing optional, but due to like the new thing, I would highly recommend that you pair. Again, you can pair with anybody that you haven't paired with yet, or yeah, anybody that you want to, I suppose. We have 6 challenges, and these 6 challenges, I would recommend highly to just do them in order. Like, don't try to jump around, just start with one, then move down. Like, they're in this order for a particular reason. The first one is just SQL basics. The good thing about this is I can walk over and just figure out like whether or not something works, because it's either going to work or it's not going to work. The READMEs are pretty robust this time around, so just kind of like read through them and let me know if you have any questions. This first one is basically, let's just do SQL stuff. Let's just write a bunch of SQL. We're going to do schema design, which is like that thing that I talked about where you have to think carefully and figure out which tables do I need. In each one of those tables, which columns are they going to have? We're going to do 3 things. We're going to do Grubhub online ordering, Blue Apron, and Instagram. So it's like, we have these tables, what columns go inside of them, and how are they joined together? Like, does a user have many posts? Does a post have many users? Does a user have many comments? Like, how do you associate all of these things together? Then we're going to write the schema SQL for that particular thing. We will need to unfortunately modify it afterwards. And then read SQL queries. This might be useful. Actually, I think we already read this, right? Maybe not. And SQL queries. So yeah, you want to do these in order, starting from top, going all the way down to the bottom. And it is a pairing optional day. Do you have any questions, anyone? SQL is fun. It's definitely something I particularly enjoy because there's one right answer, which is a good thing. And it's not like there's no tricks. There's no real big tricks to it. No, it's like there's one way to do it. So it's very like in order. Like it makes sense to me. It's like math, yeah.
I'm just
It's
curious.
not like math.
I'm just curious. When would you ever use plain text? Because if I'm using like tell me about your stuff, I'm gonna use a string, or I'm gonna do
Plain text and string are synonymous in this case.
Okay.
Yeah. So whenever you save anything to the database, whenever you save anything to a database and it's saved as text, it's just a string. Can literally consist of anything.
Okay. Just not anything security wise, then not plain text.
Oh, that's what you mean by plain text. Yeah. So don't store passwords as plain text, meaning like if my password is password123, don't save password 123 to John at codeplatoon.org. All right, let's get to it.